what we're doing is we're going to look at the different forms that we've used so far in this class. And we're going to start analyzing those forms because there is reasons for all the forms that we've done. Believe it or not, there's purpose behind it. So, first slide. Easiest slide in the world. Where's the vertex of this first graph? The vertex. It's 1, 1. It's right here. Okay, this isn't going to fly with me today. The vertex is at 1, 1. Where's the vertex of the other one? -3, -4. Hi. Yeah. Turn the other one, please. Yeah, thank you. That's where your vertexes are. Is the first one a minimum or a maximum? It's a minimum. That's the absolute lowest the point will ever happen. Is that one a minimum or a maximum? Maximum is the highest point you'll ever get on that graph. That should be review. It should be like, give me. Here's 6 questions where you need to find the vertex. I want U6 to find the vertex of A. Agree on it, write the answer on the board. I want U4 to find the vertex of B. Agree on an answer, write on the board. U4 the vertex of C. Write on the board. You guys E. You guys E. You guys F.
Yeah, right.
All the answers are right.
Yeah.
So everybody's right. That took a long time.
What?
Right? You could probably do all 6 of those in the same amount of time it took each group to do 1. If you guys just knew a nice little trick. I'm going to tell you the trick. So, all of these questions were in our general form. Remember our standard form, our A times X minus P squared plus Q. They're all in that form. We use that form for a reason. Another word for that form is vertex form. Because your P value is your X. And your Q value is your Y, or your vertex. So if we look at this first one, our P is just 1. And our Q is 2. Our vertex happens to be 1 and 2. Not a coincidence. It works that way every time. Go ahead.
So this is just style.
Right, so the X, the P, the value switches. So it looks like -1, but it's actually just 1. And then the Q is simple. That one matches up nicely. Second one. P is -3, Q is 6. That's your vertex. Next one. P is 4, Q is -7. That's your vertex. Works every time. If it's in standard form. Which it is. So that's this one doesn't look like standard form. But it is in standard form. Your P is just 0, and your Q is 5. So you can rewrite this one to be 3x minus 0 squared plus 5. That's the same thing. They just simplified x minus 0 at the ends. This one also doesn't look like standard form, but it is. Just add a +0 on the end of it. This one, same thing. plus 0. That's important. P is your x coordinate, Q is your y coordinate, that gives you your vertex. It'll work every time. Okay, so we have some information now. Along the top of this slide, you'll see the many names for standard form. There's standard form, it's also called vertex form, it's also called completed square form, all the same junk. You might see it written out with an H and a K, because someone along the way just decided it could be written that way. It's stuck. So now you have two ways of writing it. We almost always do P and Q. But next year, you'll do H and K, and they'll add one more term to it. That's kind of why we show you why H and K does exist. Okay, what does your A value do in standard form?
It like decides if it's like skinny or fat and fills it.
Yeah, your A value stretches it, so it makes it skinny or fat, and it tells you if it's facing up or if it's facing down. So that's what your A value does. Up or down. That also means it tells you if you have a max or a min. If it's facing down, you have a maximum. If it's facing up, you have a minimum. What does our P value tell us? Somebody else, Ty. Yeah, the P value tells you, so it shifts left or right. It also tells you something else. What to tell you? What did we just learn? It tells you the x value of the vertex. What's your Q value tell you? Somebody else. Come on. Yeah, Q value tells you how much moves up, how much moves down. So it shifts up. What else does it show you? Yeah, shows you your Y value of your vertex. That's a pretty key slide to understand. Okay, oh, you were still writing that down? Sorry. We'll finish that. We're going to do a chart. We're going to fly through that chart. And you're going to see how easy these things can be without graphing. We taught you how to graph so that you can always fall back on graphing. It's your safety net. If you can't remember the easy way, graphing is kind of a long process that'll save you when you're in big trouble. And now you should know all the quick ways. What's your vertex for this? 0, 0. Your P value is 0. Your Y value is 0. Where's your maximum or your minimum? It's a max or min? It's a minimum because it's opening upwards, right? Positive A means it's opening upwards. So you have a minimum point. So you have a min. Axis of symmetry is always it's 0. It's the x value of your vertex. Domain, always x is now next to the reals. Your range is going to be y is something, then 0. And the 0 came from your y value of your vertex. Is it going to be greater than or less than? Yeah, because it's a minimum. Greater than or equal to 0. Okay. Let me find the axis of symmetry. It's always your x value of your vertex. Always, yeah. Okay, let's look at this next one. What's your vertex? 0, 1. It's your p value and your q value. It's going to be a maximum or it's going to be a minimum? It's going to be a minimum because it's a positive a. My axis of symmetry, x equals 0 again, because that's my x value for my vertex. The domain, what is it? The next one. What's my vertex going to be? -7. Oh, wait. What's our range going to be? Exactly. You do. I just don't understand. Do I have a maximum or a minimum from an x1? Maximum. Why is it a maximum? Because it's a negative a out front. Where's my axis of symmetry? X is an element to the reals. Every time. Unless there's a word problem, your quadratic, x will always be an element to the reals. Y is greater than or equal to 0? Not quite. Less than or equal to 0. Because it's a maximum point. So that changes the symbol in between. 0 is the largest possible number because that's my maximum. This next one isn't in standard form. So you need to make it standard form. Add 10 to both sides. Yeah, easy. Add 10 to both sides. Plus 10, plus 10. And your vertex is at what point? -5 and... Why is it a minimum? It's a minimum because there's no negative out front. Remember, it's the opposite of what your p-value looks like. And it is what your q value looks like. Time. Yeah. Where's my axis of symmetry? -5. X is still an element of the reals. Y is greater than or equal to 10. Last one, not in standard form. Make it standard form. Subtract 3 from both sides. One, comma, -1. Is it a max or min? It's a minimum. Where's my axis of symmetry? Why is it 1? Because your x value of your vertex is 1. Correct. X is always an element to the reals. What's my range? Yeah. Easy, easy. Okay, there's a couple hard ones. We're going to skip down to the very last one. If you feel you need more practice, then after the lesson you can fill out the other 3. But we're going to go down to the bottom one because that one looks scary. It's really not scary. The first thing you need to do is put it in standard form, which means y is by itself. So you need to add w to both sides. and you get y is equal to x plus r squared plus w. Where's your vertex going to be for this equation?
R and W.
R and W. It's a negative R, and a positive W. Because remember, your p value switches, but your q value doesn't. Are we going to have a maximum or a minimum? I'm going to have a minimum because there's no a value that's negative. Where's my axis of symmetry? X equals negative r. My domain. XER, always. Yeah, range. Y is greater than or equal to W. Those are good test questions because they're not numbers, so you can't rely on your calculator.
Where do you look for the A value? Is it in front of the bracket?
It's always in front of the brackets.
Because there you see.
If there's nothing there, it's positive 1. Yeah. Good question. Okay. Before we do this slide, let's do a quick review on the types of forms that we've seen. So what's the one we've been working with called? That's standard. I can't write over there. There's standard form. What's another form we've worked with? General form. Beautiful. What's another form we've seen? Quadratic, but quadratics were in general form. So these are all quadratic equations, just in different forms. Factored form, that's what I was looking for, yeah. Factored form. And there's really no other ones that we've really worked with. Yeah, that's the same thing as standard, just a different word for it. So standard, vertex, completed square are all the same thing. Okay, there's a purpose behind all three of these. They all help you find different things. Standard form helps us find our vertex, and it also helps us find if it's opening up or down. General form helps us find our y-intercept. It also helps us use the quadratic formula if we ever want to. Factored form helps us find our x-intercepts. General form helped us find our y-intercept.
Standard means our vertex, right?
Standard is vertex, correct. So, depending on questions you get, you need to know which form you want to work with. For this question we have right now, if you read it, which format would work best? Factored. Why would factored work best? So because you have your x-intercepts. So whatever they give you, work with the format that works with that. They give us x-intercepts. Right there. So we need to use those x-intercepts to our advantage. We can't use those to our advantage in standard form. That doesn't help us at all. There's nowhere to place those. Right. Yeah, so let's write it out. Y is equal to, and we know our factored form always looks something like that. Something times something. And we always know it's x something x. What is going to go in these blanks? It's going to be +2 and -4. Here's why. It's opposite because your actual answers were 4 and -2. The actual value of x that worked for an x-intercept was 4. So if you put 4 in here, it'd make it 0. So it has to be the opposite. So when you're putting your x-intercepts into factored form, it's reverse. Not yet, not yet. There's one last part of factored form that we haven't written in yet. If I gave you this, and I times it by, I don't know, 1,000,000, would the x-intercepts still be the same? Yeah. What if I times it by 2? What if I times it by -10? Still the same. So there's an invisible number out here that we call A. That you could take these factors, multiply it by anything, and the same value of x would still give you that x-intercept. So it would still make it 0. 0 times anything is still 0. Time. Yeah, yeah. That's a good question. We always wanted general form, so we always made y 0. But the y has always been there. Okay, now we have a function. Functions aren't complete unless you can fill out all the variables. Variable a here, not filled out. So we need to find a. Any suggestions on how we're going to find a? Henry.
You gotta replace x and y with the point that you got to in -16.
Exactly. So you take the point they gave you, there's your x, there's your y. If you plug those numbers in, you can then isolate for a and find what a is. So let's try it. X is 2, y is -16. So -16 is equal to a, 2 plus 2, 2 minus 4. -16 is equal to a times 4 times -2. -16 is equal to a times -8. A is equal to 2. I did that pretty fast. I want to look up and see how that worked. So I took my x value, I plugged it in everywhere I saw x, put my y value, put it everywhere I saw y, and then I simplify. 2 plus 2 is 4. 2 minus 4 is -2. 4 times -2 gives me that -8. Divide both sides by -8. And a is 2. This question didn't ask me what is a. Never asked. It said determine an equation. We found our equation, but it was missing an a, so we went and we found a. Your answer is this equation, but with a as 2. So your final answer would be y is equal to 2x plus 2, x minus 4. That would be your final answer. Those are good thinking questions. Any questions on how that all works? It's a lot. Connecting a lot of topics.
You have the hardest to get.
For this type of stuff? Yeah. It never asks for a. It asks for an equation. The equation has to have an a. That's a good question. So, it has a lot of y's and a lot of x's. It can only have one a. Like if you drew this graph, right? It has lots of y's, lots of x's, but only one.
So, what is a? No. Or just.
It wouldn't tell us anything about the graph. It would tell us the stretch. That's all it's telling us. Yeah. Here's another type of question. First thing you got to do is figure out what form is going to help you. So an equation of a quadratic function with a vertex of 2, negative 5, and a is equal to negative 2.
It's like general form.
General form or standard form? It's called standard form. It's vertex form. Vertex form. So remember our form is y equals a x minus p squared plus q. Why would that be helpful for us? Because they told you an a, and your vertex gives you p and q. That's p, that's q. Emily. Pardon? So the formula when we write it is always minus p, and then if p was a negative, then it would change it to a plus. Yeah. But make sure you always use that formula with the negative p. Okay, that's easy then. We picked the right formula. Sub in the numbers that you know. Y is equal to negative 2 x minus 2 squared minus 5. The question says find the y-intercept. So you could put this in your calculator and you could find your y-intercept. Or you could do it by hand, which is the right choice. If you want to find your y-intercept and you're in vertex form, your x is equal to 0 and then you need to solve it. If you're in general form, it's your c value. This isn't general form though. So to find your y-intercept, you make x equal to 0. And then solve. Zucker.
X actually 0 or it's brackets, so in this case it's 0.
X is actually 0. So if you think about it,
Yeah, it's still the same.
it's not,
Yeah, it's negative 2.
no. So, if you have a graph, you have a y-intercept, that means it's something that crosses the y.
Oh,
So it could be here, could be here, could be here, could be anywhere. All those points have something in common. It's that x is equal to 0. That's why we make x 0. Not the brackets, but the actual value of x we make 0. Because every y-intercept has x equals 0. Has to. So it's y is equal to negative 2, 0 minus 2 squared minus 5. Negative 2 squared is just 4. 4 times negative 2 is positive negative 8. So y is equal to negative 8 minus 5 more. It's not your final answer. So we got y is equal to minus 13, negative 13. The proper way to say it. If you're asked for a point, which is what they've done, they've asked you for a point. They asked for your y-intercept. That's an actual point. You need to give the coordinate. 0, negative 13. It's important to know what they're asking for. How do we get 8? So 0 minus 2 is negative 2. Squared is 4, and then 4 times negative 2 is negative 2. Okay, that's a good question. So if we had a graph like this, We don't know where the y-intercept is, right, London? We don't know where the y-intercept is, but we know it's somewhere along here. X has to be 0 to be a y-intercept. That's just a fact about y-intercepts. Determine the axis of symmetry of a quadratic equation with x-intercepts -4, 0 and 10, 0. What form would be useful? Factored form would be useful, but really understanding what we're working with is more useful. Think about it for a second. We have a graph. We have no idea what it looks like. All we know is it's a quadratic, and we know that there's 2 points. Right here, and right here. 10 and -4. We know something about quadratics. We know that they're symmetrical. We know that there's some imaginary line that goes right down the middle of our quadratic. That means that imaginary line has to be the same distance from each point. If it's truly symmetrical, that means this point is just a mirror image of that point. They just folded over each other over that axis of symmetry. So if you can find the middle point between -4 and 10, that'll tell you where your axis of symmetry is. If you ever have 2 points that are on the same level, these 2 points on the same level, they both have y = 0. If you can find the middle of those 2 points, that's your axis of symmetry. In this case, it's 3. 3 is right in between -4 and 10. If you're not sure how you get that, you take your larger number, you add your smaller number, you divide it by 2. It's 6 divided by 2, 3. That's how you find it. It is important that we know how to write x-intercepts, or axis of symmetries. We write them as x = 3. That's much quicker than going into factored form, picking an a value, and figuring all that out. That's a lot of work. Little tricks are what get you through tests. Make them stress-free. You look at something like that, and it's like, oh, that's a nice little trick. That's the answer. X = -3. That's your answer. That's your axis of symmetry. Time. Positive. Did I say negative? Oh, I said positive. Negative. That's a good question. We actually can't do that in factored form. So you couldn't figure it out. And the reason is you have your factors, but you don't have an a value, and you don't have a point with x, y. You have to have one of those things. And you don't. So you could do factored form, then guess and check your way through. But that's going to just drive you crazy. I think you can pick an a value for anything you want and it would work out. I'm not sure. I don't think it would. It would be a lot more work, that's for sure. Yeah. Everyone. Okay. Determine an equation for this graph. These are great questions. The first thing you always need to do is pick a form you want to write it in. What's a form that would make sense for this one? Vertex. Why would vertex form make sense? Because we got vertex. You got a vertex, use your vertex form. Right? Let's do it. Y equals A bracket X minus P. My P value is 3. Squared plus Q. My Q value is 2. We're stuck. We don't have an A value. How can we find an A value? Pick a point on the graph, use that X and that Y, and plug it into your equation, and then isolate for A. You can't pick your vertex. Don't pick your vertex as your point. It won't work. You'll find that A is 0, and that's no good. So, pick another point on the graph. I'm going to pick this point. My reasoning for picking it. They picked it for me already. They put a dot on the graph. If there's ever a dot on the graph, use that dot. And it's the closest dot to the origin. So it's the least far away from 0, 0, which means small numbers, which means easy numbers. That's my logic. This one is 1, 4. So plug those in. Y is 4, it's equal to A 1 minus 3 squared plus 2. That's 4 is equal to A times 4 minus plus 2. 1 minus 3 is negative 2. Negative 2 squared is 4. Okay.
Why are we not like acting like those as 2 by that doesn't make sense.
Right here?
Yeah,
Like making it equal 0? That's your question.
No, it just messes me up because when you have to like separate the 2 binomials, but it's not anything.
Yeah. I think you're mixing up 2 concepts. Right? Like using that binomial theorem, like that's useful for us when we're trying to factor things. Not useful for us when we're trying to find our A. We're going to subtract 2 from both sides and then divide by 4. That's for our friends. And we get 1 over 2 is equal to A. I subtracted 2 from both sides. So it's 2 on the left, and then I divided by 4. So it's 2 divided by 4 is equal to A. 2 divided by 4 and 1/2 are the same thing. Just simplify it. Subtracted 2 from both sides, divided by 4. 1 over 2 and 2 over 4, same thing. Okay, we're going to do the same thing on the second graph. Am I good to erase that? Yeah, sorry. Plug that into your equation and that's your answer. Because it's not asking what's an A value, it's asking for an equation. Okay, let's finish off. Sorry, I skipped that step. I thought we were good. Your final answer is not A equals 1/2. Your final answer is Y is equal to 1/2 X minus 3 squared plus 2. That's your final answer.
So you always take your original equation.
No, it's just 1/2. Yeah. Yes, it's your equation with the A value subbed in.
On this graph, I feel like we got A value didn't have a negative value.
No, it'd be good. Ty. Oh, I got a question. No? Okay. Are we good for the next question? Which format do you want to use for the next question? Vertex form. Same form. We have a vertex, so use it. Go ahead. Try to figure it out on your own. Check your answer with me when you're done. if you did do that question before we had to leave, check your answer and see how you did. So,
If I were to watch
Just about to finish.
Oh, multiply.
no. Here's the policy. So, we had a graph. We knew we had a vertex. So we used that vertex to our advantage by using vertex form. Got it. Got it.
On here.
Yeah.
Have it going to 2 minus 1 equals.
I actually, that's wrong. Yeah, it should be minus 2. Because that point's not at 1. Sorry, good call. So it's minus 2. Which means that's going to be 12, which means our numbers are actually nicer. So I fell for my own trick. Yeah. So this vertex is at 4 and negative 2. I put it at 1 just because it's the first line, but I wasn't paying attention. Our lines are going up by 2. Good catch, Ty. So it's 2, 4, 6, 8, 10, 12, 14. Right? So it's going up by 2s. I used the wrong vertex. So we switch our vertex to be negative 2. That's good. Subtract 2 for both sides, and we get, add 2 to both sides, and we get negative 12. It's equal to a times 4. The 4 came because 2 minus 4 is 2. Negative 2. Squared is 4. Soccer. I picked a point on the graph, and I picked a point that they gave me. So if you look down here, where I'm pointing right now, they gave us that point. Right there. So we need to use it. It's at 2, negative 14. So that's where those points came from.
That would be your negative 2.
I added my negative 2 to both sides. Yeah, tough. You could. So if you use the other point, if you use 6 and negative 14, you would get the same answer. It would still work. Oh, yeah, sure. This one would be 12 divided by 4. It should be minus 2. Good catch, Ty. All the steps are the same. The big thing is knowing which format you really want to work with. If you don't pick the right format, you make your life really, really hard. If you pick the right format, your life's pretty easy. These ones. Questions that used to be hard and time-consuming, now they're fast. Because we know lots of tricks. Here's our quadratic. It's in vertex form. Is it going to be opening up or down? Down. Why is it opening down? Yeah, it's down, and it has a maximum. Because it's a negative a value. Where's my vertex? Negative 2, negative 3. Awesome. What's the equation of the axis of symmetry? X equals negative 2. Remember, it's the exact same thing as our x value from our vertex. Or it's the other p, like the reverse of p. Our intercepts. These could be painful, hard to find. But if you use some common sense and use your wise ability to be so smart at quadratics, you know that there's no x-intercepts. Where's your vertex?
Oh, yeah.
Negative 2, negative 3. It's right here. And it's opening down. So it'll never cross the x-axis. So there's no x-intercepts. So you don't even need to look for them. But there are y-intercepts. How do you find your y-intercept? Make x 0. So to find your y-intercept, you make x 0. That's your equation. With x is 0, it's y is equal to negative 2 times 4 minus 3. That's y is equal to negative 11. But remember, don't put negative 11. That's not your y-intercept. Your y-intercept is at 0, comma, negative 11. Yeah, if you put y equals negative 11, you're not getting a mark for that. That's not a y-intercept. Your y-intercept is 0, comma, negative 11. What's your domain going to be? XCR? It's always XCR. Nice and easy. And what's your range going to be? Yep. Y can be any number less than negative 3. Because negative 3 is a maximum point. That's the highest it could ever get. Don't worry about that.